Hello everyone. Today we have discussed about the data structures. What is meant by a data? A data is a collection of information. What is meant by a representation? That is, what is meant by structuring? That means the data structure is a way of organizing all data items that considers not only the elements stored but also the relationship to each other. That means what is a data? A data refers to a different ways of data or data, and structuring affects the design of both structural and functional aspects of a program. What is meant by an algorithm? An algorithm is a step-by-step process. To finish off the program, we must and should know the algorithm and data structuring. What is the structure of the data and what is the algorithm? Then only we have to represent a program. You know that an algorithm is a step-by-step procedure to solve a particular function. That means algorithm is a set of instructions written to carry out certain tasks, and data structure is the way of organizing the data with a logical relationship between them. To develop a program of an algorithm, we should select an appropriate data structure for that algorithm. This algorithm that associated with the data structure to form a program. Data structure are normally categorized into two ways, that is primitive data structure and non-primitive data structure. The primitive data structure can be divided as a data types, that is integers, floats, characters and pointers like that. And non-primitive data structure can be divided into two types, linear data structure and non-linear data structure. First we have to discuss about the primitive data structures. There are basic structures and directly operated upon by the machine instructions. In general, there are different representations on different computers. Integers, floating point numbers, character constants, string constants, pointers and etc. These are all categories for the primitive data structures. Non-primitive data structures can be divided into two types, linear data structures and non-linear data structure. What is meant by linear data structure? The data can be represented in a memory in a sequential order that can be represented as a linear data structure. The examples for linear data structure are array, linked list, tags and queues. Non-linear data structure. What is meant by non-linear data structure? The data can be represented in a not in a sequential order. That means in a dynamic change. That means the elements can be stored in memory is it dynamically. The examples for non-linear data structures are graphs and trees. There are more sophisticated data structures. They are derived from the primitive data structures only. The non-primitive data structures structuring of a group of homogeneous and heterogeneous data items. That means same data type and different data types can also be whole data. Lists, tags, queues, trees, graphs are examples for primitive data structures. Non-primitive data structures. Non-primitive data structures can be divided into two types, linear data structures and non-linear data structures. In linear data structures, there are the examples for stacks, queues, linked list and arrays or examples for linear data structures. And non-linear data structures that can be, there are trees and graphs or examples for that. The design of an efficient data structure must take operations to be performed on a data structure. The most commonly used operations on data structures are creation, insertion, updation, searching, sorting, merging and deleting. That means we have to create a data, select some data and updating is possible. Updation is also possible, searching some elements from data and sorting in a ascending order or descending order and merging elements and deleting an element. Sorting we have to use the bubble sort, merge sort, insertion sort, selection sort, like that we have used several sorting techniques are there for sorting in an elements in ascending and descending orders. A primitive data structures is generally a basic structure that is usually built in the language such as integers, floating points, and non-primitive data structures is built out of primitive data structures linked together, that is linked list, binary search trees, ABL trees, graphs, etc. In array, what is an array? An array is a finite ordered collection of homogeneous data items. What is meant by finite? That means we have to must and should define a finite number. That means we have to define the number. The number can be finite number and homogeneous. The homogeneous means same data type can be used in full data. Whatever you have to take the data must be in a homogeneous data. That means all are integers or characters or floating points that can be, we have to select. It means an array can contain one type of data only, either all integers, floating points or characters like that. Declaration of array can be taken as whatever you have to take the data type and array name and with size. You have to mention the size of an array. So for example, you have to take the integer value, array contain the elements 10. So we have to declare it as int array of 10. Where int specifies the data type or type of an element's array can store. Array is the name of the array and the number specified inside the square brackets that the number of elements of an array can store. This is called the size or length of an array. The individual element of an array can be accessed by specifying the name of the array followed by index within the brackets. The first element of an array has the index 0. Index starts with 0. It means the first element and the last element will be specified as array of 0 and array of 9 because we have taken the 10 elements. So index starts with 0 and ends with 9. The elements of array will always be stored in a continuous memory location. That means we have to take the elements from 0 to 9. That elements can be stored in memory in a continuation manner. That means 0, 1, 2, 3 and like that only. That cannot be stored in a dynamic locations. That can be stored in a continuous locations. Where the location can be stored first starting index is 0, that can be stored in 100 position, then 101 position the next value can be stored, and next one that can be stored in 102 position. That means if you have to take the integer values that can hold the 4 bytes, that means starting with the 100, then the first value can be stored in 100 and the second value can be stored in 104 because the integer value can take the 4 bytes of memory. The number of elements that can be stored in an array, that is the size of the array, and the length can be given as upper bound minus lower bound plus 1. For the above given array, we have to take the elements. How many elements are there? We have to find out. Means that we have to follow example, equation, that is upper bound minus lower bound plus 1, that is upper bound is 9 and lower bound is 0 plus 1. That means we have to take the 10 elements. So 0 is the lower bound and 9 is the upper bound for an array. Array can always read and write through loop. If you read an one-dimensional array, it requires one loop for reading and another for writing for an array. For example, we have take the two loops for I equals to 0, I less than or equals to 9, I plus plus. It is used for the reading an elements from the given elements. We have to read an elements from the given consolidated statements. For writing an array, we have to require another first statement, another looping, and we have to represent printf statement. Scanf is used to read an element and printf can be used to display an element in a consolidated statements. If you are reading and writing two-dimensional arrays, it requires two loops, and similarly the array of n-dimensional we require n loops. We have some operations, creations, traversing, insertion, deletion, modification of elements, merging of arrays. These are possibilities for insertion for common operations applied in an array. That means we have to traverse an array for traveling all the elements from starting to ending. We have to traversing an element and insertion of new element. If the size of an element, the maximum size has some elements only, then we have to insert a new element. If the maximum size is whole, then overflow is occurred. If deletion is possible, then delete an element. Otherwise, if the array is empty, then underflow is occurred. Modification, if some element is already inserted, that can be modified with some other element, then that possibility is also occurred in arrays. Merging of arrays, that means two arrays can be taken and the two arrays can be merged by some another array. That can be also possible in arrays only. Linked list. What is meant by a linked list? It is defined as a collection of variable number of data items. Lists are most commonly used in non-primitive data structures. An element of list must contain at least two fields, one for storing data and another for information, that is other for storing address of the next element. That means we have one node, means we have called it as a nodes. In a node that can be divided into two categories. The first one can be stored as a data and another one can be stored the address of the next element. As you know, for storing address, we have a special data structure of list. The address must be a pointer type. Technically, each such element is referred to as a node. Therefore, a list can be defined as a collection of nodes. For example, there is a head. Head means that stores the elements for the starting element. Starting element address can be held at the head position, and the next in a data and next pointer field contains the next element address, and then next element address can be stored in the previous node, and the last element address field is filled with null element. Types of linked list. There are different types of linked list: single linked list, double linked list, and circular linked list. What is meant by a stack? A stack is a ordered collection of elements like arrays, but it has a special feature that deletion and insertion of elements can be done only from the one end, that is called the top of an array. Due to this property, it is called the last in first out mechanism in a data structure. It can be through of just like a stack of plates placed on a table in a party. A guest always takes off the fresh plate from the top of the plates, and new plates are placed on a stack at the top only. It is a non-primitive data structure. When an element is inserted into the stack or removed from the stack, its base remains the fixed where the top of stack is changes. Insertion of element into a stack is called push, and deletion of an element from stack is called the pop. The below there is a algorithm and there is an operations takes place on a stack. The push and pop operations can be taken on only the top of the stack only. The top is called as the top is also called as a pointer, because the insertions and deletions can be possible at only the top position only. The stack can be implemented into two ways, using arrays and using pointers, because using the arrays means we have must and should declare the maximum size of a stack. Using pointers means you should not want to declare the maximum size, because it uses a linked list, that means dynamic representation can be possible in that way. What is meant by a queue? A queue or first in first out type of data structure. In a queue, new elements are added to the queue from one end is called as a array, and another end, that means at the front end we have to remove an element from the front end only. The people standing in the railway reservation row or an example for the queue. Each new person comes and stands at the end of the row, and the person getting the reservation confirmed get out from the row and from the front end only. In the given example, we have taken 5 elements 10, 20, 30 and 40 and 50. At 50 is the last element, so it is called as a rear position, and 10 is the starting element, it is called the front element. So at the last element we have to add an element to the queue. That means we have to declare the maximum size. If you declare the maximum size is 5, then already the 0 to 4 elements starts the index with 0, and 0 to 4 elements are already declared. So if you want to insert another element, means it contains an overflow condition. If you want to insert another element, that means the maximum size must be in the increasing order. That means if you have this size 6, then we have to insert another element. If you want to delete an element from the queue, means we have to delete at the front position only. If you want to insert, that can be occurred at rear position only, and if you want to delete an element, that can be occurred at front position only. The queue can also be implemented in two ways, that is using arrays and using pointer implementation. Using arrays means it can be static representation. That means you have to represent the maximum size. If you are using the pointer implementation, then the dynamic implementation, then we don't want to represent the maximum size, then we have to represent it in a linked list representation. So the dynamic implementation can be occurred. Thank you.